Hello out there. Today's lesson is going to be a quick summary of how to solve linear systems when the linear systems are expressed in slope-intercept form. So first of all, reminder, this is slope-intercept form because when I read the equation, I can tell the slope is 1/3 and the y-intercept is 0 2/3. So that's why I call it slope-intercept form. But first of all, that's a linear function, just that top red box. That represents a linear function. And in fact, we should remember that to graph a linear function is to show all of the solutions to that equation. The way that we graph is we try to find a couple of easy to find solutions, like 0 2/3 is Captain Obvious. And my slope is 1/3, which means 1 day later, if I had 2/3 of a dollar, 1 day later I'll have 1/3 more for a total of 1 whole dollar. So over 1, up 1/3. A better way to do that might be to say every 3 days you get an extra whole dollar. So from 2/3 of a dollar, 3 days later, I get an extra dollar more. If I combine both of those plus the y-intercept, that should be clear that all of the solutions to the red equation are on this line. Please remember that there are infinity points on this line, therefore there are infinity solutions to this equation. Now, that's not a linear system, that is a linear function. And the linear function's solutions are represented by all the points on this line. Well, similarly, I can look at the blue line as another linear function, which says I have $2 in debt, and then every 7 days I get $5 more, so 7 days later I will be up to $3. So I take those points, 0, $2 in debt, 7 days later I have $5 more, and I use those 2 points to create all of the solutions to the blue graph, Now here's the big idea about what a linear system is. If you have a linear function and you pair it with another linear function, then you should understand that there are infinity solutions to the first line and there's infinity solutions to the second line. However, when combined as a system, those infinity solutions are brought down to just one solution. So what is a solution to a system? It would be an XY combo that makes the top equation true while also making the bottom equation true. Notice 0 2/3 is a solution to the red line. But if I put in 0 for x in the second equation, the y is equal to -2, not 2/3. So when x is 0, we do not have a solution to the system because we end up with different solutions for both lines. However, it appears as though the two lines intersect at the point 7, 3. I'm going to verify this, but it looks like when x is 7, y is 3, will be a solution to the bottom equation. 5/7 of 7 is 5. 5 minus 2 is 3. So 7, 3 is a solution to the bottom line. But if I put 7 in for x here, I get 7/3 plus 2/3 is equal to 9/3, which is also 3. So what's significant about the point 7, 3? It is a solution to both equations at the same time. So the point that the lines share is the solution to the linear system. This is a linear system. It is solved by finding the point of intersection. That is the coordinates that both lines share as solutions. So you are going to graph the first line, infinity solutions, graph the second line, infinity solutions, and use that to pinpoint the one solution that will be true for both equations. That one solution is the solution to the linear system. So that's your vocab. As for the method, we're simply going to say, well, let's make this y equal to that y. In other words, let's make 1/3 x plus 2/3 equal to 5/7 x minus 2. So that is the first step in solving the system would be to set the y's equal to each other, and it creates an equation with just x's in it. Recall from first semester, fraction busting. I want to get those fractions out so I don't have to clunk around with all those common denominators and so forth. So I multiply by 21 because 3 goes into 21 and 7 goes into 21. After distributing, we end up with 7x plus 14 equals 15x minus 42. Remember, 7 into 21 3 times, 3 times 5 is 15. Here, for example, 3 into 21 7 times, 7 times 2 is 14. That's how I got these numbers. As you can see, though, the equation is much easier to solve and collect like terms. I'm going to subtract 7x from both sides, add 42 to both sides, divide both sides by 8, and we get x equals 7. At this point, I'm going to stop and make sure that on my graph I show x is 7, or at least near that area. If it's near in that ballpark, I'm probably right in my algebra. Now I'm going to continue by going to the second or going to the first equation, putting in x equals 7, and finding out which y goes with it. And it says y equals 3. Again, that matches my graph, so I'm feeling really good. But just to make doubly sure, I'm going to go into the second equation. I'm going to put in x equals 7 and show that that also gives me y equals 3, which it does. Therefore, I've found the solution to the system is the point 7, 3. I verify that by using both equations, but I also verify that by going to Desmos. I type in the first equation and the second equation. I could show that the lines match. You can see my graph matches. They look the same. And I could also notice that the coordinate intersection on Desmos is the point 7, 3. So in my work on my homework slides, not only am I going to show all the work that I did by hand, but a quick little snapshot that shows, look, I'm absolutely certain that I'm right because all of this work here is confirmed by the Desmos work here. That's a lot going on there. I just wanted to go real quick and show you step by step by step, because this is an algorithm. It's a process, step by step by step. If you follow each step completely, then you're going to have perfect work. So to start with, I show all the solutions to the first equation by graphing. That's $2 in my account, spend $1 every 2 days. So I know that I'm going to have $2. 2 days later, I'll have only $1. 4 days later, I'll have only $0. So that's how I get the first line. Second line says I have $7, and every 4 days I make $3 more. Or 4 days ago, I had $3 less. So I can say $7 to start with, and I could say back 4 days, down 3. Or I could say forward 4 days, up 3, and get the point 4, 7. Either way, I will have enough data to graph the second line. I'll label my special coordinates, and I will start to, well, first I'll make a prediction. It looks like x is -4. It looks like y is +4. So that's probably what my solution will be. So then very quickly I set the y's equal to each other and substitute in. Fraction bust. Collect like terms, find the x. Verify before I go further, does the x match the graph? Yes, it does. So I continue. First equation, put in that value for x, get y equal to 4. Does that match my graph? Yes, it does. Just to make doubly sure, I go to the second equation, put in -4 for x, and show that it equals 4 for y. Yes, it does. So now I know for a fact that the solution to the system is the point -4, 4. I show that on the graph. I show that on my Desmos. I'm good. So that's pretty much the lesson in a nutshell, you guys. Follow this process exactly the way I show you, and you're going to do great on this part of the chapter. So thanks for watching. Have a great day.